Okay, so we're continuing on. In the last video we defined a function, and we were looking at 4 different ways to define a function, and we took a look at a verbal description, and we started taking a look at the algebraic definition of a function. Okay, so just to do a couple more examples, we looked at how to find the domain of a function, but let's take a look a little bit more closely at some, we're at the algebraic definition. We have like y equals f of x. And let's work with a specific function. Maybe f of x is equal to just a polynomial. I think I probably wrote this one down before. 2x squared plus 3x plus 1. And let's play around with this notation a little bit. So what is something like f of 0? This means to put 0 in place of x in the pattern here. So 2 times 0 squared plus 3 times 0 plus 1. So my input here is 0, my output is a 1. How about something like f of minus 1? What would that be? 2 times minus 1 squared plus 3 times minus 1 plus 1. So that would be 2 minus 3 plus 1. That looks like it's 0. And so on. So how about what would f of a be? What would the expression for that be? Because this is this is not a number, right? You're going to get an expression rather than a number out. So that's going to be, you put in an a wherever you see an x, 2a squared plus 3a plus 1, right? And then similarly, what would the expression for f of a plus h be? This is just symbolic. I'm just saying, here's my original function. In that case, what is f of a plus h? And so we would just say, again, wherever you see an x in the original definition, you replace that by the a plus h here. Okay, so that's 2 times a plus h squared plus 3 times a plus h plus 1. Good. Now you're going to see this quite a bit, but let's see what would the expression be for f of a plus h minus f of a divided by h. What would that expression be? I've already got these two expressions listed up here, so we're just going to substitute those in. And in fact, maybe before I substitute the second one in here, I'll go ahead and expand it out. This is 2 times a squared plus a times h plus a times h. So don't forget to multiply both of those together, and then plus h squared plus 3a plus 3h plus 1. Okay? And so now if I plug everything in, I'm going to get a big mess, but it simplifies quite a bit. So I'm going to have 2a squared. I'm going to multiply through by the 2 now. 2a squared plus 4ah plus 2h squared plus 3a plus 3h. I'm just copying everything down. Minus, now when you carry the minus through, be sure to use a parenthesis. 2a squared plus 3a plus 1. Good. That's all divided by h. I know that's a lot of stuff, but everything simplifies quite nicely at this point. The 2a squares cancel, and then the 3a's cancel, and then the 1's cancel. Okay? And so what we're left with then, just from algebra, would be the 4ah plus 2h squared plus 3h, all divided by h. Okay, and so we have to do a little bit more algebra. We would factor the h out of the numerator here. See, that's just 2h now plus 3. Oops, I'm factoring the h out. Okay, now to double check yourself, right, you could multiply the h back in, right, and see that you get what you started with. But in that case, we won't do that. Okay, so now we can factor, or we can cancel the factors of h out, and so we're just left with the expression 4a plus 2h plus 3. Now at this point this doesn't have any meaning except just as an algebraic exercise. Okay, but this is going to be something that we're going to be computing quite a bit later on. So if you've had calculus before, you'll recognize that pattern. All right. So back to the definition of a function. I just wanted to finish off. We have two more ways of defining a function. And so let me just go ahead and summarize that, and then we'll take a look at each one. So two more ways. We have two more ways to define a function. So let's see, number 3 is using a graph. Oops. Let me get an R in there. And then part 4, the last way of defining a function is numerically. And by that I mean using a table. Okay, so the table is probably the faster of the two, because a table, you're just writing down your domain values, and right across from each domain value you write your corresponding range value. So for example, I might have 0, 1, 2, 3, and then whatever my y values are, you know, I might have 1, 4, 3, minus 1, something like that. Okay, so this is defining this relationship, right, between the x's and the y's. And so similarly on a graph, if you have x here and y here, and then a curve in this plane defines an ordered pair for each point. So if this is the point AB, we write that as AB. Then this point is on the graph if A is equal, sorry, B is equal to f of A. Okay. Oh, that's not very clear. Okay, so a point on the graph, point AB is on the graph of f. This is the graph of f. If B is equal to f of A. Okay. And so that's how a graph defines a function, right? So really, a graph defines a function kind of pointwise, right? And so geometrically then, well, on a table, we know what it means for something to not be a function. For example, if I have 1, 1, 2, 3 here, with 1, 4, 3, negative 1. In this case, this is not a function, right? Because you have the x equals 1 being plotted to both, or output. Let me say that again. You have x equals 1 being, you have an output of 1 and 4 for the value of 1. Okay, so that's why it's not a function. Graphically, what would that look like? You know, if you're sitting here at the value 1 here for x, and y is 1 and 4, right, that means that you have 2 points above a point like this. Okay, so therefore, on a graph, you can tell if a graph is a function or not. Like something like this would not be a function because for each of these values of your domain, you get 2 values of your range. And so this right here is called the vertical line test for a function. And that says that if the graph intersects any vertical line through more than one point, let me summarize that, through more than one point, the graph is not the graph of a function. Okay, it's just a relationship, but it's not a graph. It's not a function. That's the idea. Because again, a function, for each domain value, you can only have one range value. Okay. Good. So that gets us through the general description of functions. And so in the next video, we'll be talking about some specific functions like lines, quadratics, maybe some other stuff. Okay, see you then.